In this video, we'll look at bash shell commands and how to write and run scripts. If you don't already have the cities file, enter nano cities and enter this list of cities. And we're actually going to enter Delray Beach, beach. Press Ctrl O to write out and Ctrl X to exit. Let's cat cities in order to display the contents of cities. But we're going to pipe that into the sed command. This is a stream editor, which is a non-interactive editor. So I want to look for any lines that have Delray in them and substitute beach with lake. Now this doesn't actually change the original cities file. This just modifies the output. If we enter a G, that says do this globally. So it says for every occurrence of beach, replace that with lake in a specific line. Let's also say to delete any lines that have the word Delray in them by entering sed space / Delray /D. Enter tail space / etc /PASSWD. And this will display the last 10 lines of the PASSWD file. And this is the password file. And this file has all the user accounts in it. Let's pipe this into the awk command. We'll enter an option of -F, and we'll say that our delimiter, that's what's going to separate the fields, is a colon. Put in open curly brackets and enter $1, comma, $, and I'm counting over because each one of these fields is $1, $2, $3, $4, and the last field is $7. And we'll include those open and close curly brackets and the print command inside of single quotes. And you'll see that this pulled off just the first field, which had the user's name, and the last field, which was the default shell. Hit the up arrow key, and we'll replace $7 with $3. And as you can see, that would be the user ID. If I enter $6, that's going to be the path to the home directory for that user's account. And enter clear. Let's enter the grep command to look for any occurrences of pi in the etc/PASSWD file. Now, instead of entering pi, enter your user account name. That's the user account that's before the @ symbol. And let's pipe this into the cut command. And we want to cut out just those fields that are field 1 and field 7, which was the default shell. Replace this with 6, which is the home directory. And we can also cut just the third field, which was the user ID. Now we can also pipe this into the translate command, which says find any occurrences of the colon and replace that with the space. Let's pipe the set command's output into less so that we can page through and see all of the environmental variables that are defined, and hit the space bar to page through and type in Q to quit. Echo space $PS1. And this is one of the environmental variables that is defined, which is for the prompt for the shell. Let's change this prompt temporarily to be an open square bracket. The \U is an escape character for the username, \T is for the time, \D is for the date, and the $$ is also included to say if it's a regular user, display a $. If you're logged on as root, display a hash mark. Let's change this. To \U, which is a username, at \H, which is the host name, and leave in the $. Let's add in \W, which is the absolute path, and let's change directory to the test search directory. If you don't have the test search directory, type in mkdir space test search, and you'll see that there's a /test search. That tilde indicates the absolute path to the user's home directory, in this case /home/pi. If we want to see the relative path rather than the absolute path, enter \W, again cd into test search, and you'll see there's no tilde / in front of test search. If we want a really minimal prompt, enter ps1 equals double quotes $$. Enter sudo-s to log on as root, and what you'll see is you'll have a hash mark at the end rather than type in exit and clear. And let's enter the echo command and echo back out the values of a number of the other environmental variables. Echo $home for the path to the home directory. Enter echo $pwd, which is the print working directory. Enter echo $path, which shows us the search path for executables. We can also create our own environmental variables. Enter myvar equals, assign the value of myvar to the string that's my variable. To see the value of the environmental variable, enter echo space $myvar. Let's pipe the output of the set command into grep and look for myvar. Let's pipe the output of the env command into grep myvar. Now if we export myvar, now that will be available in other environments. And you can verify this by again piping the output of env into the grep command, and this time you'll see that you'll find myvar. If you type in env space pipe space less, you can page through and see all the environmental variables, including myvar. Press Q to quit. Let's look at aliases. These are used for command substitution. Typically, you have an alias for a longer command that is executed when a shorter command is input. Or you can run multiple commands by separating those commands with a semicolon. So let's create an alias for who, and write equals who, semicolon, W, semicolon, ID. Now when we enter who, each of those commands is executed. W command and the ID command to see what the output would be. Now let's enter another alias. Let's replace LL with a long listing from the ls command, all, including the hidden files, and I to additionally display the value of the inode. Enter more /etc/profile. The etc profile file has a number of aliases inside of it, and the profile file is run every time a user logs on. If a user accesses the bash shell, then the etc/bash/bash.rc, that's runtime configuration, is also executed. For a particular user, the .profile file is run. And if the user's logged onto a bash shell, each user also has a file that's the .bashrc file. And again, you can see the aliases and the environmental variables, as well as and you can see the scripts which are run and the UMask to set permissions. And you can edit these in order to set a customized shell prompt, a customized set of aliases, a different UMask, or even run a script. Let's make a new user account. Enter sudo space add user test user 2 and put the password of just ABC123. Let's switch to user and use the user's profile. Enter su dash and test user 2, and then enter nano.profile, and we'll set a different UMask. Recall that the UMask specifies the default permissions for any files that are created. So for our directory, it's going to be 777 -027, which says that the user is going to have read, write, and execute. The group owner is going to have read and execute, and everybody else on the system has no permissions. For the files, the user will have read, write permissions, the group will have read only, and any other user on the system will have no permissions. I also want to run a command, so I'll enter the date command, and I'll set a new prompt by entering PS equals double quote \U for the user, \W for the absolute path, and $$, so we can actually see a prompt with a $, logged on as this regular user. And again, these are the 4 common tasks you want to perform in your profile file. Press Ctrl-O to write out, and press Ctrl-X to exit. Exit this user account, and log on again as test user 2. Press the up arrow key, and let's log in as the test user 2. And you'll see that the date was displayed. That was our one line, or the one line of script we added. LL, that's our new alias. We've got our prompt, which is the username, absolute path to the directory, and the $sign prompt. If we type an alias, we'll see a list of all the aliases that were defined for this user. And again, they could have been in the etc/profile file, they could have been an etc/bash/bashrc. We added the LL alias in the .profile file. If you type in set and pipe that into less, Again, we can see all of the environmental variables. And hit the space bar and press Q to quit. Enter nano.profile, and let's create our own environmental variable. Enter var5 is equal to, double quote, Linux is fun, close double quotes. And press Control O to write out and Control X to exit. And then enter exit. And hit the up arrow key. And again log on as test user 2. And let's echo space $var5 and we'll see the message Linux is fun. Enter the UMask to see the value of the UMask. And again, that UMask was set in the .profile file. And this UMask is just set for this particular user, not for all users on the system. Let's write a script. Enter nano space script 1. Enter hash exclamation point /bin/bash. And we'll say that we'll run this in the bash shell. We'll put a hash mark and write written by your name. And that's a comment. It's just for you as a user to know who wrote the script or what the script does. We'll enter the command read my name. That'll actually create a new environmental variable called my name, and then we'll execute the echo command and print out my name. We'll also run the date and the who commands. And press Control O to write out and Control X to exit. Enter bash script 1. And I enter Dr. Horvath. Hello, Dr. Horvath is printed. Now, because a user may not know that they need to input any data, we'll echo enter your name. Let's run this script again by entering enter /script 1. Now you'll notice when we try to run the script in this fashion, we can't run it. Because we need to use chmod a+x to say, make this script executable. Again, run the script, enter your name, and you'll see your name echoed back out, and then the date command is run. Let's edit a new script, the info script. Enter nano space info script. This script is going to use a number of if, else statements to display different information based upon a user's choice. We'll create a menu that says enter P for processes, W for who is logged on, and M for memory and disk utilization. And enter a close double quote. Read in the user's choice by entering read choice. Press Control O to save or write out and Control X to exit. And let's enter chmod a+x on the info script. This adds the execute permission to the info script, and then let's run the info script and just enter P. And that's to test that so far our code doesn't seem to have any syntax errors. And let's change the menu to say enter your choice. And then let's add in a number of if statements. And say if the choice is equal to P, then execute the command PS space AUX, and that will show all of the processes running on our system, both the user and daemon processes. Now the reason we need to put double quotes around P, W, and M is because we're comparing the string that the user entered, their choice, with another string that's going to either be P, W, or M. And those open and closed square brackets are required. And there needs to be a space after the open square bracket and before the closed square bracket. Now we're going to run free-m. That's going to show us what the physical memory and virtual memory utilization is. And the du-h is going to show us our disk utilization in a human readable format. Otherwise, we're going to print out unknown choice. Now notice that the statements are elif, not else if, that you might see in some other programming languages. Now we'll end the if, elif, else block with fi. Press Control O to write out and Control X to exit. Now notice when I typed in P, I got an error. And this is a syntax error. This means I violated the rules of the language and I need to correct my code. Enter nano info script. Press Control O to write out and Control X to exit. And let's run this again. We still have an error. Let's go back again and enter nano info script. The variable name choice should not have a $sign in front of it in the read statement. Enter nano info script and notice there's no $sign in front of the choice. Let's say that if the user entered an uppercase P, we also want to accept that as an option. So we'll use the OR Boolean operator to say if the choice is equal to P or capital P, lowercase w or capital W, or if the choice is M or capital M. Then we'll execute the code which is associated with that if or elif statement. Press Control O and then press Control X. And let's run the script again. Let's copy InfoScript into InfoScript 2 and enter nano InfoScript. We can write more compact code when we have an OR statement. If we use a case statement rather than a series of if, elif, else statements. So if our choice is P or capital P, we'll run the command PSAUX. If our choice is W, lowercase w, or uppercase W, we'll run who and W. If our choice is M, lowercase m, or uppercase m, we'll run df-h and free-m. If there's any other options, we'll put in unknown option. And we basically enter case in reverse, just like we did with fi to end an if block. We enter ESAC to end the case block. Let's run this script up, and we'll see we have a syntax error. Enter nano m for script again, and replace those two square brackets with two semicolons. Press Ctrl O and press Ctrl X. And then let's run the info script. Let's create a new script, the file script. Enter nano space file script. Enter the echo command with enter the file or directory name. And that'll be in double quotes. Let's read in the file name. And we'll test, is this a file? By using the -f option. If this is a file, we're going to print out the name of the file and print it as a file. We'll test to see, is that file readable? Do we have the read permissions for this file? Now this is actually a nested if statement. It's one if statement inside of another if statement. And we'll print out, you have read permissions. And then we'll use the cat command to print out the contents of this file. And we'll end that if statement. We'll write another if statement that says, do we have read permissions to the file? If we do, then we'll print out, you have write permissions. Now the reason we're using an if statement rather than using an elif block of code is because, again, the user could have read, write, and execute permissions. Now if we have write permissions, we're going to touch the file, which updates the timestamp on the file. And we'll end that if statement. If you have execute permissions to the file, then we'll print out, you have execute permissions. And then we'll run the script by earning bash $file name. Now for our outer if statement, we're going to say, test, is this a directory? If this was a directory, we're going to echo, the file name is a directory. And then we'll use the ls command to list the contents of that directory. Press Ctrl O to write out and Ctrl X to exit. Let's set execute permissions on the file script by using chmod a+x on file script. And then let's run the file script. Enter info script, and you'll see that script runs. Let's enter test search, and we'll see that's a directory. If I enter my file doesn't exist, so I don't see anything. If I enter cities, I'll see that cities is a file, and I have read permissions, and I also have write permissions. And this completes the lecture on Bash shell commands and scripts.